So we had 2x, and then we had 3x plus 4 raised to 4/3, and then plus, and I'm going to write it, let me copy this is, to 1/3. Okay, so first of all, I'm going to just rearrange this term, and I'm going to write normally 4x squared, 3x plus 4 to 1/3, and then 2x, 3x plus 4 to 4/3. And always remember, we start with what we see in front. And I see 2x and I see 4x squared. What should I factor out? Anyone would like to help, please?
2x.
Excellent. So we have to do that first. Then we look and see that there is another factor, which is 3x plus 4, and now we have to choose the power. Can anyone choose the power? Who answered first, so I know? I'm taking notes now who answers my questions. So who was the first one who answered? Was it Sophie or no? It was somebody else?
Hello?
Yes.
It's Tam.
Tam.
I found out a study room.
Awesome. Welcome. Great job.
The answer is 1/3 for the power.
Yes. Excellent. Very good. Awesome. Thank you, Tam. So now we have to decide what is left in parentheses, in brackets. Indeed. Indeed, 3x plus 4. How did we get that? Who was that?
It was me, Kevin.
Kevin.
Kevin G.
Kevin G. Very good. Perfect. So 4/3 minus 1/3 is 3/3, which is power 1. Excellent. Now this piece is out. I reach the plus sign. I have to copy the plus sign. And what will I copy next?
2x.
Excellent. Thank you, Alex. So we are copying 2x. Perfect. We combine like terms, and we have 5x plus 4 in brackets. So I will rewrite 2x, 3x plus 4 to 1/3, and in parentheses 5x plus 4. Perfect. Any questions? Is this okay, everyone? Okay, I'm ready for your questions. Anything you have for us, from anywhere, from the homework, from Pearson, from anywhere. Any questions?
I have a question about the current problem. Could you use one of your color markers, kind of mark what operations you associate with one another? I hope that makes sense. Like when you got the the 2x parentheses 3x plus 4 over 1/3. From the previous operation above that, I'm not clearly seeing what was pulled out to get to that position.
So I have 2x here and I have 4x squared here.
Yeah, you took 2x out.
So 2x is common to both.
Mm-hmm.
Then 3x plus 4 is common to both.
Okay.
And I have to choose the smallest power.
Okay.
So 2x is out, this is out, but 4/3 minus 1/3 is power 1. That's why this is, I don't need parentheses, but it has power 1. 4/3 minus 1/3 is 3/3, so that's power 1.
Okay.
From 4x squared we took out 2x, so we have a 2x. But 3x plus 4 to 1/3 is already out. Now, to better understand this step, maybe it would be to multiply this by this. 2x, this times this, we copy the base and add the exponents. 1/3 plus 1, power here, 1, it's 4/3. 2x times this times 2x is 4x squared times 3x plus 4 to 1/3. So whatever I put in here in brackets, has to work. This times this has to give me this. This times 2x has to give me this. If it doesn't, this is false. Maybe a better example would be like x squared plus, let's say, x to the 4th. I factor out x squared and I have 1 plus x squared. Why? Because x squared times 1 is this, and x squared times this is this. In the same way, this multiplied by this piece is this. And this multiplied by this piece is this. Is that better?
Yeah.
Okay, perfect. Other questions for me? Anything else? Anyone needs any clarification on anything? Okay then. So we are back to this handout and we are trying to finish it up. And we did not get a chance to look at any division. They're all the same, but let's choose a division. So we worked on factoring to simplify, using different rational exponents, natural exponents, negative exponents, and so on and so forth. But we did not look at ratios. So let's choose a ratio. Anyone would like to choose a ratio? 92, 102. The handout is posted.
Can you do the second one?
The second one, perfect. Let's start with the second one, perfect. So we have 9 minus, so this is 102. And we have 9 minus x squared, and the power is 1/2 plus x squared, 9 minus x squared, and the power is -3/2. And everything is divided by 9 minus x squared. Good, excellent. So there's nothing we can do to the denominator, but we are focusing on the numerator first, and we have to find common factors. Are there common factors in the numerator? Or common factor?
You said in the numerator?
Yes? Is there a common factor in these two terms? One term plus another term.
9x squared, 9 minus x squared,
Very good. Which power?
to 1/2. No, to -3/2.
Excellent. Very good. Awesome. Who was that?
It was Kevin.
Kevin, thank you. Perfect. Good. So now, the power is indeed -3/2 because we have to choose the smallest of the two. Now remember, from 1/2 we have to subtract -3/2. So I'm going to do it here. From 1/2 we subtract -3/2. What is the power?
I'm sorry, this doesn't really answer the question, but in the like handout you have, is it? I think it's to -1/2, not -3/2.
Thank you so
The
much.
exponent.
Thank you so much. Thank you so much. Excellent.
Can you still keep going with the incorrect exponent so you can explain that? No, I want to understand it. If it was -3/2.
Right. So let's finish it now because I already changed it, and then we'll do it again with -3/2. Absolutely. So, -1/2 minus -1/2 is how much?
1.
Exactly. So then we have 9 minus x squared plus. This is completely out. What is left?
X squared.
That's it. And thank you, Charles. And these two are gone. So now I bring this to the denominator, as we discussed. So it's 9. I have 9 minus x squared. And this comes to the denominator, and I'm sure you agree, is the square root of 9 minus x squared. And this is final. Do we understand the steps here before we do the problem again with the negative 3 halves? Anyone?
I have a question.
Yes, please.
So we had a negative exponent on the numerator, right? So what you just did now, was it just switching them so it's not negative anymore?
Yes. So let me refresh your memory on this rule. So every time we have a power, an exponential notation put to a negative power, that's my page 2. So a to negative n is 1 over a to the nth power. Let's say x to negative 1/2 is 1 over the square root of x. Yes, most of the time we would prefer no negative exponents in the final answer. Most of the time. But then you can say, but most of the time I don't want to see a radical in the denominator. Okay, fine. So you will rationalize and you'll have the square root of x over x.
Didn't it cancel out because we got 1 from negative 1/2 minus negative 1/2? It just becomes 1. So there's no x.
Say that again.
So wouldn't it cancel out the 9 minus x squared to, yeah, that? Because we,
Cancel out with what?
with, never mind,
So you want to cancel this out with what? With what quantity?
I'm trying to say that because the exponent became a 1.
The exponent of this became a 1. I cannot change the exponent of the factor that I pulled out. This
Yeah, okay,
is
that
the
makes
exponent
sense.
1.
Never mind.
This is carved in stone. I cannot change it. The only thing I can do is bring it to the denominator because it's a negative exponent.
Yeah, okay, I understand.
Perfect. Do we have other questions? So we can go on to the other variant. Other questions on this one? Okay, so let's create a new problem. So the problem was 9 minus x squared, and that was to 1/2 plus x squared, 9 minus x squared to negative 3/2. And this is 9 minus x squared. Perfect. So the same idea, everything the same. We have to factor a 9 minus x squared to negative 3/2 this time. And 9 minus x squared. In this case, we have 1/2 minus 3/2, which will be 9 minus x squared to power 2. And plus x squared. That's the only difference. And now I have to square this. And then add x squared. And everything is the same. So this goes to the denominator. So it will be, because it's 3 over 2, we have 9 minus x squared squared and the square root of 9 minus x squared. I pulled out 9 minus x squared. So now we have to square this. How many terms do we get? When we square a binomial, how many terms do we get?
You'll get a trinomial.
Excellent. So we have 81 minus 2 times the first times the second, plus the second term squared, plus x squared, which will have to be combined with this. So the final form, x to the 4th minus 17x squared plus 81 over the existing denominator. So the situation is a little bit more complicated because the power became 2 and now we had to square that. No other difference. Is this okay? Any questions for me here? Anyone? Moving on. Is that okay with everyone? Can I get a sign? Anything?
Yeah, we're good.
Okay, so let's move on. Now the last piece here is dealing with complex rational expressions. So these are called complex rational expressions. Complex, 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 and you see this a lot in calculus. So we are looking at 76 and 78 and 84, 74, 100, and 105. Which one would you like to start with? These are very important questions or topics. Should we start with 76?
Yeah, you can start there.
Okay, perfect. So here's 76. 4 plus 1 over x squared, everything divided by 3 minus 1 over x squared. Sorry. Perfect. So first, we look at the numerator. So what is the least common denominator in the numerator?
X squared.
Of course, there is only one denominator. It's a silly question. Thank you. Good. So what do I write at the top?
4x squared plus 1.
Excellent. Same thing for the denominator. I know you're going to say x squared. What do I write at the top?
X squared minus 1.
Excellent. Perfect. Now remember, x cannot be 0, as we know. How do I divide two fractions? I have two fractions. Yes? Go ahead. Zach, go ahead.
Then multiply them.
How?
You put the denominator x squared on the top, and then 3x squared minus 1 on the bottom.
Okay. I have to add one more restriction here. 3x squared minus 1 cannot be 0. These are mandatory restrictions for the expression to exist. First, the initial denominator, then the new denominator that was created. All we need to do now is simplify. There is nothing else we can do. 4x squared plus 1 over 3x squared minus 1. And this is it. So let's take a moment and see if we have any questions on this problem. Any questions here?